In this video, we will be going over how to expand using the power property. We've already done the other direction, and we have simplified using the power property. But in this one, we're going to go the other direction. So let's look at our first example. A refresher on what is the power property of logarithms. That power property states that the log base b of m raised to the n is equal to n times the log base b of m. So we can use that property to go back and forth between those two versions. Example 1, we have log base 9 of 4 raised to the third. So that matches the first part of our property, this guy over here, and we want to convert him so he matches the second one. So all we have to do is take that exponent of 3 and move it to the front as a coefficient. So we would have 3 times the log base 9 of 4, and that would be our answer. Let's look at another example. In this example, we have log base 8 of 7 raised to the second. So again, it matches the first one on the left, and we want it to match the one on the right. So we take that exponent, and we're going to move it out front. So we have 2 times the log base 8 of 7. Let's look at a third example. So here we have log base 4 of the cube root of 3. We can rewrite that cube root as a power. So we have the log base 4 of 3, and we can rewrite that cube root as a 1/3. So now it matches, and we can go ahead and move that exponent to the front as a coefficient. So 1/3 times the log base 4 of 3. And typically, when you see logs, we don't have a fraction as a coefficient. We would typically write that as log base 4 of 3, all being divided by 3. Because dividing by 3 is the same thing as multiplying by 1/3. Either this one or this one would be an acceptable answer. The second one is probably going to be the more common one that you would see. Let's look at a fourth example. Here we have log base 12 of 11 raised to the fifth. So again, it matches, so we're going to take that exponent and move it out front as a coefficient. So we have 5 times the log base 12 of 11, and we have our answer. Let's look at example 5. Here we have log base 7 of 10 raised to the 1/2. Same principle. We can use our power property to take this exponent right here and move him out front as a coefficient. So we have a 1/2 times the log base 7 of 10. We typically won't write it as a coefficient of a fraction or that 1/2, so we would typically write that as log base 7 of 10 being divided by 2. In example 6, we now have some variables involved instead of all numbers. But the process and the concept is still the same. It matches our power property, so we can take that exponent and move him out front as a coefficient. So we have 6 times the log base 5 of x. Example 7, we have a log base 2 of 25 raised to the m. It matches our power property, so we can take that exponent and move it out front as a coefficient. So we would have m times the log base 2 of 25. Example 8, we have a log base 4 of 13 raised to the u. Again, it still matches our power property, so we can take that exponent, even though it's a variable, and move it out front as a coefficient. So we would have u times the log base 4 of 13. And that would be our final answer. In example 9, we have log base 18 of p raised to the 4th. So again, it matches our power property. We can take that exponent and move him out front as a coefficient based off the power property. So we have the 4 times log base 18 of P for our final answer. Let's look at one last example. Example 10. Here we have a log base 3 of the fourth root of x. We can rewrite that fourth root as an exponent. So log base 3 of x, if you rewrite the fourth root, that would be a 1/4 power. So now we have what we need. It matches our power property. We can take this exponent and move him out front based off what the power property tells us. So we have a 1/4 times log base 3 of x. And again, we generally would not leave a fraction as the coefficient. We would typically write that as log base 3 of x over 4. And that would be our final answer.